Last time we were here, okay, we have talked about some basic concepts about classes, and we also know what is a class. Basically, it's a blueprint, okay? Basically, it's a blueprint. So we also learned what is a property. So a property is a class member that holds a piece of data about the object, like this one, right? So we have a private field underline name. So that is a private field, which is known as a backing field, and is used to hold any data assigned to the name property. You see, underline name is starts with a small letter. But that is for property name. Okay, you see that we have a property name defined here, so which is used to we have get and set, right? Get means we would like to read value. We would like to return value and to your project and use the value in the instance. So set means we would like to set the value, right? Last time we get a example, which is this example. If we have an instance of the pet class, okay, instance of the pet class, which is the name is my dog. So if we put my dog dot name on the left hand side of the equal sign, basically we would like to do what? Assign its value, right? It equals Fido. Assign its value equal to Fido. Another example is we put my dog dot name on the right hand side. In this case, we would like to read the value from my dog dot name. Okay, so that is get and set. Okay, get and set. So you need to understand this is a property. Okay, this is a property. So inside the class, we have a field, which is backing field. But that part, underline name, that part is hidden. It is private. It is only available inside the class. So any objects, any code outside the class cannot access underline name directly. However, we would like to use capital, right? Capital name, N-A-M-E name, for the property. Any other thing can access this instance, right? The property name property by using capital NAME name, okay? So you have to be clear about this concept. That's why you see inside this property, in order to manipulate the property, we have get and set. Get means we want to read the value from the hidden field, right? Set means we would like to write the value of the underlying name, this field, okay? Get and set. These are two different concepts. So the backing field, the private backing field is a variable that stores a value assigned to the property with which the backing field is associated. So it is declared to be private to protect it from access by code in other classes, which could lead to accidental corruption of the data. You see that we do not manipulate the backing field, underline name directly. Instead, we have declared this part, right, for the property. So being declared private, the data stored in the backing field can only be accessed with the use of the object's accessor, which is considered desirable. So this is sometimes referred to as data hiding. So now let's explain get and set a little bit. The get accessor, if included, is a method that returns the property's value while its return statement. So it is executed when the property is read. For example, I want to say I had a string, right? String name, a string now, so string A, X or A equals my dog dot name. Okay, it means I would like to read the name of the pet class instance, my dog. The set accessor, if included, gets the value stored in the backing field and assigns the value to the property. Set means we would like to write something in the backing field. Okay, It has an implicit parameter named value that is automatically created by the C# compiler. It is executed whenever a value is assigned to the property. You see here, right? Value is, the term value is in blue color. It means it's a reserved term, right, in C#. You do not claim a variable value or a constant value. Instead, you can use it directly, and this is a result value. C# knows, right, when we use set and use value, so will be read from inputs, okay, will be read from somewhere, okay, and you need to write the value to the property name, or to the property name. So sometimes you may prefer to what? Read-only properties. For example, right? Let's see, your U number, okay? So we assign you a U number when you join USF. That will be permanent. For example, when you graduate, it's the same. After a couple of years, right? You want to check your student record in the system, it's the same. Maybe after a couple of years, you want to go back to USF to get a master's degree, it's the same, okay? It is always the same. It means if the initial value is set up, it cannot be changed for any reason, right? So this is read-only properties, okay? Read-only properties. So read-only property can be read, but not modified. So you see that when we only want to read the property, so we use get without set, okay? That is read-only property. Okay, in this case, we will not have the set part. Instead, we will only have the get part, okay? That will be so a read-only properties. Sometimes you want that for a class. So auto properties, sometimes a property simply gets and sets a value of a backing field without performing any other operation. Auto properties simplify the code for such a property. For example, right? For get, I just want to return the value without any further manipulation. Okay, for example, I will read a student name from the input, but the backing field name will be stored as a sentence. This is student whom, right? If in this case, so you need some more manipulation with the input, okay, with the input. So you need all the statements. However, if we just read the property directly and write the property directly in the set part, you can ignore the statements in the curly braces for both get and set. You can have get semicolon, set semicolon. That will be good enough, okay? It is a simplification of the full code. Usually, my suggestion is, so if you're new for computer programming, you are new in computer programming, try to write the full code. Why? Because when you write the full code, it helps you to remember what's going on. And actually, all the statements of full code, it means the code on the right, can give you all the details of the class, right, of the property name, how it works. When you become more professional, it means when you have accumulated more experience in computer programming, you may want to be like this on the left, okay? This is more professional, and because we have practiced enough with the full code, you understand everything, right? Writing a simplified version is still very clear to you. It will not bring any confusion, okay? That's why my recommendation. In the beginning, when you try to practice, so try to write everything. However, when you become more and more experienced, you can use simplified version, okay? Simplified version. So with auto properties, a hidden backing field is automatically created, as well as the code for the get and set method. In fact, most programmers prefer to write an even shorter version of the property like this, right? You see, in this case, so we just write public string name get set. Only one line, no multiple. So you can initialize an auto property like this. Public string name get set. That's a full all code for the property name. You can see fiddle. It means when we create an instance, okay, that name property will be set equal to fiddle automatically. Okay, you can see that there are multiple simplified ways to write this kind of thing. But for beginner, I recommend you to write everything because it can help you to understand. When you become more professional, you can use any simplified version you like. Okay, you like. So it is read-only auto properties. If you leave out the set keyword in auto property, the property become read-only. It's a simplified way, okay, for the read-only property. See, we don't have set. We only have get, and fiddle is the initial value, okay, initial value of the property name. So here is one example. Assume that the class pet is defined as follows. It is pet class. Remember, we have a backing field name. We have a constructor. Constructor means, so constructor can be used to initialize some or all properties. In this case, so when we create a new instance of the pet class, we would like the name property to be empty. There is a value, but it's empty. Okay, empty. So we also have a name property like this one. Okay. So write statements to define property name, okay? I give you example because in the exam, sometimes I may ask you to write the full class. Usually it will not be in this case because if you need to write a full class, that might be one of the last two questions, more difficult. So for regular coding questions, they're simple, okay? One line, two line, okay? Statements, because I want to make sure so you have learned all the basic concepts and techniques from the lecture. I'm not challenging you, okay, for complicated questions. That is not my objective because I want to make sure you learn those basic concepts and that's good enough, okay? You do not need to be fancy. There is no tricky questions, okay? Even for, you see, based on the midterm, you can see that even for the last two questions, so they are just combinations of some simple questions, okay? For other questions, they are directly simple questions. But for the last two questions, they're combination of simple questions, okay, simple questions. So you can see that here you need to write for the name property, okay? You need to write codes for name property. So for name property, right, we have learned, you can see that you can get, return, backing field name. Set is for backing field name equals value, okay? And this is also a simplified version if you want. So basically, I want to make sure that you have learned the lecture slides for this question, okay? So in the exam, I may give you a different class. This is a pet, okay? I may give you a course, okay? And ask you to do something similar. You see, you just need some small revision, right? Small changes for this type of question. Okay, I will not give you too complicated questions because that is not my objective. Okay, that is not my objective. So next topic is parameterized constructors and overloads. So what is that? So here is one example. Okay, let me explain the intuition of that. Okay, so in this example, right? I want to do what? I want to do. I want this class is a bank account. Okay, bank account. Basically, it means that if a new customers asks the agent to open a new account for him, right? And there will be some initial balance. So the customer may give you a check, may pay you by cash, okay? May transfer some fund from his existing bank account, right? So they can give you maybe $10, okay? Maybe $20.50. All these kind of things, okay, for a new customer. but they will lead to the same bank account with an initial balance, right? It means there is some input. I will get some money from the customer. Then I will open a bank account for him. Based on the amount of money, $10 seems to be a whole number, okay? $10.50 seems to be a decimal number or a double number, okay? I have multiple different types of inputs, but all of them will lead to same type of bank account, okay? That is why we have overloading. It means for constructor, okay, when we want to initialize the value of some property, some fields, we can deal with multiple different types of inputs, okay? Multiple different types of inputs. So a parameterized constructor is a constructor that accepts arguments. You see in the previous one, right? Constructor, there is no inputs, okay? Pet in this pair of parentheses, so there's nothing. It's empty. However, if we have this problem, which is bank account, right? For this constructor, there is a parameter, which is decimal starting balance. Okay, decimal starting balance. So a class can have multiple versions of the same method, known as overloaded method. What is that? So it is, for example, public bank account decimal starting balance. Public bank account double starting balance, right? So it means for constructor, multiple versions can be decimal, can be double, maybe int, okay? Can be multiple different versions. How does a compiler know which method to call? So binding relies on the signature of a method, which consists of a method's name, the data type, and argument kind of the method's parameter. For example, if we have bank account decimal, bank account double, when you see an input which is decimal, C# will go to the first version automatically. If C# sees that the input argument is double, then C# will go to the second one, okay? Go to the second one. So when a method is overloaded, multiple methods in the same class have the same name but different parameters. You see, for this kind of constructor, right? So the name of this method constructor is all deposit. All these 4 different versions, they are all deposits, okay? But for the first one, the input parameter is decimal. Second one, double. Third one, int. Fourth one, string, okay? C# can differentiate all these 4 different types. The name of the method is the same, but the input parameters are different. That is how C# differentiate these 4 different versions. Okay, 4 different versions. So constructors can also be overloaded. For this one, bank account, right? So you can have parameterless. There is no parameter version. We can have decimal version. We can have double version. Okay, there are multiple versions. Compiler will find matching constructor automatically. For example, if we want to create a bank account class, new bank account without any input, empty, then C# will use the first one. So if we want we have a parameter or argument which is 500M. 500M is a decimal number, right? C# will go to a second version, okay? Based on the type of the input parameters, C# will go to the corresponding version, okay? So this is how C# differentiate these different kinds of overload or constructors, okay? Multiple versions of constructors. So here is one example. If the following overloading methods have been defined, we have bank account, decimal number. Consider the following statements and figure out potential issues. First one, bank account, new bank account, we have an input 100M. We have a decimal type overload, so it's okay, right? So for the second one, bank account is new bank account 100. So 100 is what? It is int, right? Remember, decimal can be compatible with int, right? C# will go decimal for this number, so it is also okay. Okay, but for the third one, bank account, the input is 100.0 without an M. It means the input is a double number. So the double version of the constructor is not in the declaration part. So it's an error. Okay, it's an error. Okay, it's an error. So when you try to work on your project, okay, so you should be pay attention to those kind of things. Okay. So the next topic is storing class type objects in arrays and lists. So previously, we just learned class. What is a class? What are classes and what is an instance of a class? Now we would like to create what? A sequence, a bunch of instances of the same class. So in this case, we can use arrays and lists. Okay, it can hold multiple different instances of the same type. Remember, for array, right? We can hold a sequence of int numbers, a sequence of decimal numbers, a sequence of strings. Okay, either one is fine, but each one is just a value, right? But in this case, an array can hold what? Can hold a sequence of instances of the same class. Okay, from the same class. So this is one example. So we first declare a constant size equal to 4. So cell phone equals new cell phone size, okay? Phone number 1, number 0, 0 means number 1, okay? Index number 0 means number 1, first element, new cell phone. Phone number 2, new cell phone, right? Basically, it means that each cell in the array will be an instance of the cell phone class, okay? In total, we have 4 different instances or 4 elements of the same type of class. Okay, same type of class. So you can use a loop to step through the array. For example, here in this part, we declare each individual elements one by one, right? In the bottom part, we use a for loop. Okay, we will have 4 iterations. In each iteration, we will initialize one element as an instance of the cell phone class. Okay, so you see that for this part, if you replace cell phone, the predefined class cell phone, with what? With int, decimal, double, it's the same, right, as what we have learned from the array chapter 7. In chapter 7, we have learned how to declare a int array, decimal array, double array, right? In this lecture, so when we have defined a class, completely defined a class, we can use the class to declare an array of class instances. Okay, it will also work. Okay, it can also work. Okay. So there are also other ways to initialize array elements. You can see that these formats are very similar as the concepts we have learned, right, in the array section. Okay. For example, you can initialize the array elements in the declaration statement. In this case, cell phone, if you replace with int, right, it is the same. Phone equals what? We have a pair of curly braces. Inside this pair of curly braces, remember, if you have a number array, int, you have 14, 16, 74, 66, right? You have numbers. If you have 4 numbers in this pair of curly braces, so it means C# can read, oh, you have 4, in total we have 4 elements for this array. In this case, right, you can see that for initialization, we have new cell phone, new cell phone, new cell phone, new cell phone, right? It means there are 4 instances of the cell phone class. C# can read, first, phone is an array for the cell phone class. And there are 4 instances in this array. Okay, in this array. You can also initialize an array and assign its elements with references to a class. Okay, in this case, we can do bank account equals new bank account with a parameter 1,000, 2,000, 3,000, 4,000. Same thing, but in this case, we have an argument. We have an argument. Okay. So if you replace cell phone bank account by with int, decimal, double, you can see this is almost the same as we have learned in chapter 7. Okay, chapter 7. So for list of class type objects, you can create a list to hold a class object. Okay, so in this case, we have a list. List will be for the cell phone class. We have a new list cell phone and a pair parenthesis. That is the format to create a list. Similarly, if you replace cell phone with int, decimal or double, it's the same as what we have learned, right? How to create a list for int, decimal, and double numbers. But in this case, we are focusing on classes. This statement creates a list object referenced by the phone list variable. Each object of the cell phone class is an instance of cell phone class to hold data. You can see that here, cell phone, my phone is new cell phone, and we can have what? My phone, the brand is this, right? Model is this, price is this. Okay, basically, so you can set up the value inside a class instance. So to add a cell phone object to the list, so we can use phone list add my phone, because add is a function, right? It's a built-in method in C# for list. Okay, it means you can add additional instance into the list. Okay, into the list. So here is one example. Assume that the textbook class exists in an application. Write statements to create an array containing 3 textbook objects. Okay, so we need an array containing 3 different textbook objects. Okay, so for this problem, I'm testing you. If you really understand, right, how to create an array of class elements, how to initialize array elements for class members. So we have multiple different versions of answers. First, answer 1. First, declare constant size equal to 3. Then you declare array of what? Of textbook textbook class instances. Then you try to initialize each element one by one, right? Index number 0, index number 1, then index number 2. Okay, that is the first one. First, declare an array for this class with 3 elements, then initialize each element one by one. Okay, one by one. So the second answer will be first declare a constant size equal to 3. Then you can declare an array of size 3, right? So instead of using this strategy, we can use a for loop. Okay, for loop. So another answer is we don't need the size constant. Instead, we can use one line of statement directly. So we can do books inside this pair of curly braces. There are 3 elements for initialization. New textbook, new textbook, new textbook. Okay? C# can read it from, we want to create an array of textbook class instances, and there are 3 instances. So there are 3 different kinds of answers, okay, in this example. So in the exam, okay, if you are asked to do a similar problem, remember, usually I will not copy the same problem. but a very similar problem. For example, I ask you, how would I say? I changed textbook to like course, right? A course class. Assume the course class exists in an application. Okay? Write statements to create an array containing 5 course objects. Okay, you can see that in this example, I changed the name from textbook to course. Secondly, I changed the number 3 to 5. That's it. Okay? Basically, it's the same, almost same problem, but you cannot just directly copy. You need to understand what's going on here, right? Then do the problem. Okay, then do the problem. Because if I just copy the same problem from the slides, okay, there may be students who will copy the answer directly, right, without understanding anything. Okay, that's why I try to make sure you have learned the course materials, and you try to prepare for the exam well. Then I give you the problem to solve. Okay. So let's move on. The next topic is finding the classes and their responsibilities in a problem. Okay, in a problem. So when developing an object-oriented program, you need to identify the classes that you will need to create before a big project. For this course, it's easy. I can tell you it's easy. At most, you just write one class. Okay. You can see in the previous labs and assignments, you don't need to write any class, right? All your code will be in the form class. Form one of the form application, the form class, right? There's no need for you to write any class. Why? Because we are focusing on basic concepts. I'm telling you this because we try to keep the course materials basic and simple. Why? Because I want you to focus on elementary or basic concepts and try to understand all the concepts well, okay? But it doesn't mean in an actual project, it is that simple. To be honest, it is very, very complicated, okay? Very complicated. For example, when you start your position, you need to write some code. Let's assume you need to write some code, okay? So your boss may throw you something. So this is a code written by a guy 5 years ago. This guy is no longer in this company. He moved on, okay? But we need to use the code, and you may need to do some revision. Secondly, you may need to write some additional new things, right? So when you get the code, you see it's a very big zipped file. When you unzip the file, you will see that there are a lot of different documents, okay? So it is extremely complicated. It means if you build your project, you do want to organize your project well, because after 2 years, when you need to work on the project again, sometimes you have to, right? You may have forgotten everything. It's quite possible. But if you have organized it well, you may just need a couple of days to pick it up. However, if your organization is bad and there are no lot of comments, then I assume you will forget. It's because I did the same thing, because sometimes I did some coding part for my project, right? And when it's done, I put it there, okay? So after 6 months, 9 months, maybe 1 year, I have to bring my code back and revise it. I almost forget everything. I have to read it through because it's my work. I may have some weak memory. I bring it back, I read it through, then I get what's going on there. I continue with my work, right? But let's assume you are working on a very big project. A lot of files are there. So try to make a nice plan is very important. It is very important. So one popular technique involving these following steps. First, get a written description of the problem domain. So what's the problem? Okay. Identify all the nouns, including pronouns and noun phrases in the description. Each of these is a potential class. For example, we deal with what? So you are designing a plan for what? For automobile, okay, automobile. Well, you will design a new car for that. So then a car is a class. Then you have what? You have for the car you have motor. So maybe motor is you have wheels. You have a lot of different things, right? Some are simple, for example, mileage is just a number, right? Some are more complicated because for seats or for engine, it is also different in some multiple different classes, right? It also needs some specified design. For example, a sports car should be different than a regular car, right? It means engine may be another class, right? Seats may be a third class. Wheels can also have multiple different versions, right? Wheels is a fourth class. You see, all the nouns, right, can be potentially defined as a class. Okay, that's why identify all nouns in the description. Each of these is a potential class. Refine the list to include only the classes that are relevant to the problem. You have a list of all the classes that eliminate the unimportant, unnecessary nouns. Okay, then you focus on the remaining terms for your class definition. So once the classes have been identified, you need to identify each class's responsibilities. The responsibilities are first the things that the class is responsible for known. Secondly, the actions that the class is responsible for doing. You see, we have properties. We also have methods, right? Like the coin class we learned last time, the toss, right? Toss method, okay? To toss a coin. So here we have some examples. The customer class has following actions. First, create and initialize an object of the customer class, okay? So get and set the customer's name, get and set the customer's address, get and set the customer's self-telephone number, okay? So we need to initialize a class object, and we need to basically read and write 3 different properties. Similarly, for the car class, so the car class will have the following actions: create and initialize an object of the car class, get and set the car's make, get and set the car's model, get and set the car's year. 3 different properties, okay? For the service code class has the following actions: create and initialize an object of the service code class, get and set the estimated parts charges, get and set the estimated label charges, get and set the sales tax rate, get and sales tax, get the total estimated charges. Okay? So you see, all these things are not computer code. They are words, they are sentences, right? Why we need that? So this is how you make a plan, actually. Okay, first, remember you get all the nouns, right? All objects, which can be potentially be possible classes, candidates. Then you eliminate irrelevant or unimportant items. All the remaining items will be used for classes definition, right? So, for example, you have customer, car, and service code, 3 different remaining terms. Then for each class, right, you need to describe what do we need to define in the class. Or in other words, what kind of computer code do I need to write in this class? These are what? Demand or requirement, right? So when you have the requirement, you can work on your computer code. Why you need that? Because things are complicated in practice, to be honest. It is not like all the projects we have worked in the class. They are not difficult because for each project, we try to focus on, first, cover basic techniques. Secondly, try to focus on the center topic, right, in these 1 or 2 chapters. This is the design for each chapter or for each assignment or lab. However, in practice, right, we are problem driven. You have a problem, you need to solve it. We cannot say we can simplify the problem, or we change the problem, or we can revise the problem. The problem is there, so our task is to solve the problem. It means it is complicated. You have to deal with a lot of different issues. Okay, so have this kind of working plan is very useful. You can see that when we have this plan for the customer class, right? So it is. So the plan in your mind, or you'll be much clearer for how to write your code based on the plan here, right? So that is how to compose your task. So write code, this is example, write code to define the customer class. The customer class has the following actions. First, create and initialize an object of the customer class. Secondly, we need to get and set the customer's name, get and set the customer's address, get and set the customer's telephone number. 3, okay? So if this is a problem in the exam, right? Basically, the requirement is given. You need to write code to define the class customer or customer. So here is the answer. Okay, here is answer. So based on all the concepts we have learned, right? First, you need to use the keyword class. Okay, and the name of the class is given, which is customer. Customer will start with a capital C. Okay. Then you have a pair of curly braces. So we need what? First, create and initialize means what? Means it is constructor, right? Secondly, we have customer names, customer's address, customer's telephone number, 3 different properties. Okay, for each of the 3 different properties, we need both get and set. It means we need both read and write, right? Read and write. So then we have constructor, read and write for 3 different properties. So for each property, first you need to declare backing fields. Okay, don't forget about this step. Okay, you need to declare 3 different backing fields. Then we have the constructor. For the constructor, right, we would like to initialize the fields. So we want name equals name, address equals address, phone equals phone. Okay, we would like to initialize. Initialize means there are 3 different inputs. Okay, 3 different inputs. Then we move on. We need to read and write or get and set the 3 different properties: name property, address property, and phone property. For name property, you need public string name. Okay, that is a property, right? That is not a method. That's a property. Inside this pair of curly braces, we need get and set. Okay, get is returning the field. Set is setting the backing field equal to value. Remember, value is a reserved term in C#. Okay, so similarly for the address property, we can have get and set. We have return the backing field address and set the address equal to value. Similarly, for the last one, phone property, we can do get and set again, right? So you see that without detailed analysis of the code, from a first observation, this problem seems very complicated. Why? Because there are a lot of lines of statements, right? But if you have understood all the concepts well, we have learned all the concepts well, then it's not a big deal, right? It is just, I need some code, 1 or 2 lines of code to satisfy each requirement in this plan, right? First, I need to create and initialize an object. That is constructor, okay? And I have 3 different properties. For each property, I need first to declare a backing field in the beginning, right? Secondly, I need to declare the property get and set. I just repeat almost same thing, right? 3 times. That is the full answer, okay? You see that if you see this kind of problem, all right, I give you this, some requirement may not be the same, not the customer. I may change it to patients, right? Patients. I change the name of the class and I will change get and set patient's name, get and set patient's address, right? Get and set patient's email address. I change the email address, right? You see that? So some requirements are different, but in big picture, these two problems are same. Okay? What you need to is to understand this example and try to revise the code given in the example, right? The structure, the big picture or the structure of the code will be almost the same. Okay, almost the same. Okay? Remember that. So in the second half, I think after this week, we have 3 weeks, right, remaining for the whole class. So in the second half of this course, I will focus on basic concepts, okay? Because I do understand things become more challenging because a lot of students are confused about some materials in previous chapters. And also you're busy for your different course projects, right? Even though this semester we're online, but you still have to take a lot of courses, okay? So if I try to make things more complicated, so you have to spend more time on these things, okay? I understand that. But you have to really to follow the lecture slides or the course materials, try to learn the basic concepts. And first, it is important to get a nice grade, okay? You always would like to prefer a nice grade, okay? Secondly, this is the foundation for you to take other courses in the future. That's why. So this is my strategy. That's why I could say that I keep explaining simple stuff time to time, okay? It is not because I'm boring. It is because I try to make things simple, okay? That is my strategy, my strategy. So the next topic is creating multiple forms in an object. Every project with a form in Visual C# has a class. So the default name of the form is form1. If you check all the projects, labs, and assignments you have finished, you will see it's form1, right? So form1 and its class is also named form1, which is stored in the form1.cs file. Okay? We have not worked on any other classes. We are staying in form1, right? Form class. A Visual C# project can have multiple forms. Each form has its own class that can be instantiated and displayed on the screen. It means, what is that? It is something like this, okay? Let me explain this to you. It is like, for example, this is some file, right? A Microsoft Word, okay? This application, right? So if I click help, okay, help, I have some options. And there's a help here, right? I click help, you see something happened. Another application sim starts at the same time, right? It means two things starts, but the help application on the right is inside Microsoft Word, because if I close it, this part is gone, right? If I close this help, Word is still there. But if I close Word, both Word and help is gone, right? It means intuitively, the help application is inside the Microsoft Word application, okay? So in this course, we will not do this too fancy stuff because we have focused on what? Windows Form application, right? So we would like to see, can one form contains another form? In other words, can multiple forms are in one project? The answer is yes. Okay, the answer is yes. So when you add an additional form to a project, you add an additional class stored in its own file. When you create event handlers for a specific form's control, you write them as methods in the form class. Okay, it means previously we only have forms1.cs. You see, when you open a project, if the interface is not displayed, you click forms1.cs, right click, right? The show designer, you see the interface, right? View code, you see the code, right? We only have one CS file, okay? If you add additional form or multiple forms to the project, then you have multiple different CS files. Each CS file is for an independent form, okay? But all these forms are in this Windows Form application project, okay? Windows Form application project. In the last assignment, we will practice this. It is very simple, okay? I will just ask you to add one form, and that form is very simple, but you need to learn, try to practice this procedure. So to display a form in your application, you need to create an instance of the forms class, okay? So you have arrow form like this. My arrow form equals new arrow form is a new class. The above code first declares a reference variable named my arrow form, creates an object of the arrow form class in memory, and assigns a reference to the object to my arrow form. After creating the instance, use show dialog method to display the form. You see why? Because the main form, when you create the Windows Form application, forms1, the main form is given. It means when you start the application, right? This default form1 will be displayed. The form you add, the additional forms you add to the form1 will not be displayed, okay? So this form has to be triggered somewhere, like the help application. I have to click the help, right? Option or the help option to activate the help application in Windows, in Microsoft Office, Word, right? Similarly, we need to trigger the new added form with what? With the show dialog method. Okay, it means if you have a menu or a button, right? So the event handler, in the event handler, if you want to trigger the added form, you need what? You need to use the show dialog method. Okay, you need to use the show dialog method. The show dialog method displays a form on the screen and gives that form the focus. Okay, it means this is the form 1. If you click your option and trigger the event handler, in the event handler, so you use the show dialog method, then the new form, the added form will be triggered. That will be your focus, and the form 1 will be in the background. Okay, like this, right? If I have this is Acrobat, okay, Acrobat for the slides. If I click help, right? I want about Acrobat. You see, this is front, Acrobat in the behind, right? So if I cannot click anything behind, I close it, right? I close it, then I can keep working on my Adobe PDF reader, right? So that is focus. Focus will be given to the new form, and the main form, form 1, will be active on the background. Okay, background. So access and control on additional form. Controls provided by the .NET framework have private access by default. A control that exists on a particular form can be accessed only by code written in that form's class, okay? But you can change the access of a control by changing its modifier property in the property window. The point is the default modifiers are private. When you want to add a button, a label, a text box to the additional form, the modifier's type will be private. I recommend you to keep it private, unless you purposely do want the modifier to be public. For example, I really need my main form to change that control, to manipulate that control, okay? Then you change the modifier property from private to public. That is not recommended. Why? Because if a lot of things are global or public, when you write your code manipulate, who knows what will happen? You make a small mistake, your program will crash. Okay, you see, when you write a lot of code, right? And you run application, your program crashes. Usually, it's very hard to figure out what's going on. When you have an error, it's possible because you can still run it, right? Syntax errors will be mentioned in C#. Logic errors can be figured out with debug. But if it crashes, there's no way to figure out anything, right? So you'll be very frustrated. It's quite possible you have to start from the previous version. I'm saying the previous version, it means you have a backup a couple of days ago. You need to go back to the previous version and redo all the things you have done, right? If you have no backup, then I'm sorry, you have to start from zero. Okay, things is terrible and nothing can be recovered. You have to start from zero. That's what I mentioned. You can see I mentioned if you work with apps.usf.edu, right? If you have no backup and things crashes, start from square zero. Okay, because nothing can be recovered. That's it. Okay. So here is the same thing. If you have a lot of things public, a lot of global variables, so things will become more and more complicated. Okay? It means a small mistake to revise something global may make your whole project crash. Sometimes nobody can explain why it crashes. Even a very experienced professional programmers cannot figure out what's going on. Okay? You have to start from, I think it's the previous version. Okay? That is very, very important to you. Okay? If you have no coding experience before, you may feel that that should not be a big issue because it seems even though I have some errors, it always can be fixed in some way, right? Because that you feel it because all the things we have worked on are simple. They are not difficult. Okay? When you are dealing with something more complicated, for example, some code with more than 20,000, which is very common, 20,000 lines stated by yourself. If it crashes, can you tell me what's the problem? No, it's almost impossible to find out what's going on here. Okay, that's why. So do not make too many public, unless you are 100% sure I want this to be public. Then you can change it. You can change it. Also, same thing. When you work on your project, keep having backups. That is very important. Okay, without backups, it's quite possible you have to redo a lot of things. Okay, redo a lot of things. So for example, suppose greeting form has a label named message label, and the message label control modifier's property has been set to public. The following code shows how, from another class, you can create an instance of greeting form, assign a value to the message label controls text property, and then display the form. For example, let's assume in the form 1, main Windows form 1 class, okay? Greeting form, my greeting form, we create a new instance of greeting form class. Then we do greeting form dot message label dot text. We are using it. Okay, remember this line. This line is not in the CSS file for my greetings form CS file. It is in forms1.cs file. It means we want to access, right, the message label control, which is just for my greeting form in another class. If message label is private, this is an error. Okay? C# will tell you this is an error. If message label, the modifier is public, then this line is correct. But be careful when you try to revise its value. Okay? So in this statement, we try to set the text property of message label to be good day. Then you can use my greeting form dot show dialog to trigger the form, because you do want to display the message or display the new form. Okay, the new form. Okay. So you will practice this in the last assignment. Okay, last assignment. So model and modelless form. A model form or dialog box must be closed or hidden before you can continue working with the rest of the application. Like I just showed you, right? This Microsoft, this Adobe, right? If I click this, this pops up. If I click, I want to continue with my PDF document without closing this information, right? I click, nothing happens. Okay, nothing happens because the focus now is locked in this current information or application. It is locked. You cannot go back to your main form form one, without closing this application, right? When I close it, I can continue with my main application. Okay, my main application. So when a model form is displayed, no other form in the application can receive the focus until the model form is closed. On the other hand, a modelless form allows the user to switch focus to another form while it is displayed. It means I open something, right? I can still go back. For example, for the Microsoft Word, right? So if I go to help, right? Help application is still open, but I can still go back to my Word without closing this help application, right? It means these two things are active at the same time, okay? If I keep help opening, the Word editing, the Word is still open. If I close it, there's no difference. Okay, there's difference. So that is what is a model form and a modelless form. You see, based on what we have learned, you see, something, right, which are common for us when we are using our laptop, actually can be written by ourselves. I don't know what's your feeling, but when I was a student, when I find out I can do this, I'm excited. Okay, even though I know that's simple, but when I see that I can also do it, I'm excited. Okay, so hopefully when you learn these simple things and you can work on these simple things in your assignment and lab, you are excited. It means you are getting motivation. You get motivated to learn more advanced techniques. Because to be honest, so for more advanced techniques, sometimes you need to read more books. You see, if you try to learn, you try to talk with your friends, how to learn program, okay? He is experienced, okay? So usually he will throw you several books. Read these books, and you try to purchase those books from either you get a hard copy or soft copy, right? When you check it, you may talk to yourself. You're kidding me. There are 1,000 pages in a textbook. How can I read it? The answer is, we are not kidding. You need to read it. Okay, 1,000 book for a coding book is ordinary. For example, a textbook. Check your textbook. How many pages are there? I think it's less than 1,000 pages. I think it's 800, 900. Okay, just for basic C#. Okay, in C4, C++, Python, most book, even simple book is 500, 600. It's easy to have 1,000 pages for a book. Okay, and another problem is you need to read multiple books because this book just for beginner. This is for intermediate level. This is for advanced programmer, right? You need to read 3 or 4 books to be professional. You may think about, is that possible? Yes, it is possible. Okay, when you are motivated, for example, you are excited about data analytics. You want to be a data scientist. Okay, you want to be a data scientist in big tech company because a lot of my friends, they are programmers or data scientists in like Facebook, Google, or Amazon, because they have high degree in this kind of data analytics. Okay, so you have to learn those kind of things. Okay, you have to take multiple courses. You have to be professional in coding. It means you have to read this kind of book. You may say you're kidding, right? I'm not kidding. For computer programming itself, to be honest, each language you need 2 or 3 books. Okay, you may ask, do I need to read books for data analytics? Yes. So for a beginner, okay, you can read a book with 500 pages because in these 500 pages, they will try to skip all the core statements, all the details of each algorithm. They will try to focus on the big picture. Okay, but when you become more and more advanced, you need to go to details of this data mining, data machine learning algorithms. Then when you find a book, you will see it's more than 1,000 pages. Okay, it's a way is very long. That's why you see, be a data scientist. Okay, it's highly paid. Okay, and it is very competitive, and it's in U.S. market. Okay, in U.S. market, so they need a lot of people in this domain. That is why in our department, the master program in BAIS is almost the most popular master program in USF. Okay, every year we have a lot of students. Okay, every year we have a lot of students. That is why it's popular. And I believe because you are undergrad students in this domain, you want to pursue, you may want to pursue your career, you are young, in this direction, right? Try to learn, okay? This is the beginning, and try to get yourself motivated, and I believe you will learn a lot from this class, and you will learn a lot in future classes, okay? I try to encourage you to learn, okay? That's very important. Also, flow of statement executions. In a model form, statements after show dialog method will not be executed until the model form is closed. It means when it is a model form, so when you show dialog, C# is waiting here. When you close it, continue, right? However, it is modelless, so C# will not wait here. C# will execute all the remaining statements immediately. Okay, that is the logic of flow of statement execution. You need to be very clear about these basic concepts. Okay, basic concepts. So another thing is static class members. What is that? A static class member belongs to the class, not to objects instantiated from the class. You see, for a car, let me use a car class, right? We have brand, right, and mileage. So each car has its own brand, right, or has its own mileage. It's unique. It means when we create an instance of the car class, then we have its own mileage. However, a static class is, for this whole class, there is only one value. All other instances, we will share the same value. There are no multiple copies of the property. There is only one value. That is why it is static. Okay, it means it exists and it is always there. Okay, so each instance of a class has its own set of instance fields and may have instance methods. Instance fields and instance methods are associated with a specific instance of a class. However, you can create a field when you can create a field, property, or method that does not belong to any instance of a class. These are known as static fields, static properties, static methods. They are static members, okay? Only one copy for everything, everyone, okay, everyone. So when a field is declared with the static keyword, there is only one copy of the field in memory, regardless of how many instances there are of the class. The following example uses a static field to keep count of the number of instances of the accountable class that are created, like this one. Private static int instance count equals 0. You see, what is it? Remember, all instances will share the same int variable instance count. There is only one instant count. It means each time when we create a copy of the class countable, right? We will first execute constructor. In constructor, we do instance count plus plus. It means we will increase 1, right, for the variable instance count. Intuitively, instance count will be used to count how many instances we have created, right? Because all instances will share the same variable, the creation of each instance will increase the variable by 1. We create 5 instances, instance count equals 5, right? It will be number of instances we have created in the application, okay, in the application. So the following code creates 3 instances of the countable classes. You could call the getInstanceCount method, which is this part, okay? From any of the objects and get the same value, you will see that it equals 3 because we have created 3 different instances. For static properties, when a property is declared with the static keyword, there is only one copy of the property's value in memory, regardless of how many instances there are of the class. All instances of the class share that property. The following example uses a static property to keep count of the number of instances. So in this case, you see we have an instant count, right? That is a property, not a field, a property, right? Property, get and set, get and set. So static property example, in this case, we also declare 3 different objects. If you try to see what is the property instance count, you will see it's 3. No matter you use get the number of instances, okay? No matter which copy you use, you will see it equals 3. It is 3, okay? For static fields example, the following code creates 3 instances of the countable classes. You could call the getInstanceCount method from any of the objects and get the same value, also 3, okay? So the key idea is for static, no matter it is field, properties, or methods, so there is only one copy there. Every single instance will use the same copy. Okay, we'll use the same copy. This is static method. One class contains a static method. It is not necessary to create an instance of the class to execute the method. A static method is created by placing the static keyword after the access specifier in the method header. You see, this is static double kilometer to miles. So all copies, all instances will use the same copy. Okay, we'll same copy. So this static property example, and we have metric miles to kilometers, metric miles kilometers. So they will all refer to the same copy. Okay, method kilometers to miles. So for static classes, static keyword can be used to declare class as static. If a class is declared static, all its members must also be static, or compiler error will occur. If a class is declared static, the compiler will not allow you to instantiate the class. Only one copy, no more instantiations, okay?